Domain and range of quadratic functions. We know that the domain of a function f of x represents the set of all values of x for which the function is defined. The range of a function y equals f of x represents the set of all values that y takes. A quadratic function has domain R, where R is the real numbers set. We are going to look at an example. Here is a function, the set of all ordered pairs such that y equals 3x squared plus 6x minus 24, where x is an element of R. To determine the range, we need to calculate the y-coordinate of the turning point, the vertex. For this, we need to calculate the x-coordinate of the turning point, and we use the formula minus b over 2a, where b is the coefficient of x and a is the coefficient of x squared. X of the turning point equals negative 6 over 2 times 3 equals negative 1. We can now substitute x equals negative 1 in the rule. The y-coordinate of the turning point equals 3 times negative 1 squared plus 6 times negative 1 minus 24 equals negative 27. So now we have the two coordinates of the turning point. Let's sketch the graph of this parabola. First, we are going to put the point with coordinates negative 1 and negative 27. And here is the parabola. The domain is from minus infinity to positive infinity, so it's the real number set. The range starts at negative 27 and goes up to infinity. Negative 27 is a square bracket. Let's look at another example. This time we have f of x equals negative x squared plus 4x minus 3. We calculate the x-coordinate of the turning point, minus 4 over 2 times negative 1 equals 2. So the y-coordinate of the turning point equals negative 1 times 2 squared plus 4 times 2 minus 3 equals 1. Now we have the coordinates of the turning point and we sketch the graph. Here is the turning point with coordinates 2 and 1. We draw the parabola. The domain is from negative infinity to positive infinity, so the real number set. This time, the maximum value of y is 1. So the range is from negative infinity to 1, square bracket at 1, because that point is part of the parabola. So in conclusion, if a is positive, the coefficient of x squared, the parabola opens upwards and the turning point is a minimum. So the domain is R and the range is from y of the turning point to infinity. If the coefficient a of x squared is negative, then we have a maximum. The domain is R and the range is from negative infinity to the y-coordinate of the turning point. Let's have a look if we have a restricted domain. Here is an example. The set of all ordered pairs xy such that y equals 3x squared plus 6x minus 24, where x is from negative 2 to 3. Now the round bracket means less than and the square bracket means less than or equal to. So the domain is from negative 2 to 3. Let's calculate the coordinates of the endpoints. When x equals negative 2, y equals 3 times negative 2 squared plus 6 times negative 2 minus 24 equals negative 24. So the left endpoint has coordinates negative 2 and negative 24. When x equals 3, y equals 3 times 3 squared plus 6 times 3 minus 24 equals 21. The right endpoint has coordinates 3 and 21. Let's sketch the graph of this parabola. We start at negative 2 and negative 24 and we go up to 3 and 21. So the domain, as we said, is from negative 2 round bracket and there is a circle there to 3 square bracket with a dot. For the range, we start at the turning point we have already calculated the coordinates of this point, -1, -27. So the range starts at -27 and goes up to 21. Notice that both ends are square brackets. Always check to see if the turning point is inside the domain of the function, the restricted domain. Here is another example. F is a function such that x is between 0 and 1, with rule f of x equals -x squared plus 4x minus 3. Again, notice that the square bracket is replaced by less than or equal to, and the round bracket is replaced by less than. So the domain is from 0 square bracket to 1 round bracket. Let's calculate the coordinates of the end points. When x equals 0, y equals -1 times 0 squared plus 4 times 0 minus 3 equals -3. So the left endpoint has coordinates 0, -3. When x equals 1, y equals -1 times 1 squared plus 4 times 1 minus 3 equals 0. So the right endpoint has coordinates 1 and 0. Let's sketch this graph. 0, -3 is a dot because it's a square bracket less than or equal to, and there is a circle at 1 and 0. The domain is from 0 to 1. Remember that we calculated a turning point for this function, and that has coordinates 2 and 1. That is outside the restricted domain, so we don't need it. The range is going to be from the minimum value -3 to the maximum value 0. So the range is from -3 square bracket to 0 round bracket.